Hey class, hope you're doing well. So today we're going to talk about what's called the comparison test. Before we jump into the comparison test, let's just quickly remind ourselves what we know about series convergence and divergence tests so far. In particular, let's remind ourselves about the integral test. So please check out today's video. So if we just remind ourselves what we've talked about so far for series convergence divergence tests, we had the test for divergence. We also had the geometric series test. And now we're starting to develop a class of series convergence and divergence tests that can be applied to a broad range of series. And the first one that we did was the so-called integral test. And just to quickly remind ourselves what the integral test did, it put the question of convergence and divergence onto an improper integral. So if this improper integral converged, we could say that, hey, our series converges. Or if this improper integral diverged, we're able to say, hey, our series also diverges. So it seems like a very useful test. And in fact, we use that test to figure out what happens for this so-called P series. So let's just quickly remind ourselves that this P series is an infinite series from n equals 1 to infinity of 1 over n to some power p. And again, what we found out about the P series for this very, very particular type of series form was that, you know what? If P is greater than 1, the series converges. On the other hand, if P is less than or equal to 1, we found that the series diverges. And to give you a sense of where we're going to go today, is we want to develop another set of set of convergence and divergence tests. And these, of course, are called the comparison tests. And the reason for introducing these comparison tests are basically are going to allow us to get around having to do possibly impossibly hard integrals. So it's going to bypass the integral test for us by using basically a different methodology for testing whether a series is convergent or divergent. And just as a spoiler, a lot of times we're going to compare our series that we're handed to something like a P series or something like a geometric series. Well, let's actually just get into what we're going to talk about today. So, our big 4 goals for today is to, number 1, motivate the comparison tests. Spoiler, it's going to get us around having to do impossibly hard integrals. Next, we're going to do some examples using kind of the standard comparison test, which I'm calling the inequality-based comparison test, where we're going to directly compare our series that we're handed that we don't know about to a series in which we know something about. And we're going to do this by setting up an inequality. Next, we're going to introduce another comparison test, which is called the limit comparison test, or the LCT. And the limit comparison test is going to be a different flavor of comparison test. I'm going to motivate this by saying, what happens when this inequality that we're trying to set up from the first kind of comparison test, when this fails? We're going to basically call on the limit comparison test to come to the rescue. But on that note, as we'll see in the videos, we could jump right into limit comparison test without ever actually trying the inequality-based test first. So the limit comparison test is typically the series test that I would jump to right away. And then lastly, we're going to do some examples using the limit comparison test. So that's what's on tap for today. Please watch the videos. I hope you enjoy them. And hopefully I'll see you soon.